This video is meant for Mrs. Rose's AB Calculus class, and it is on extrema of a function. Okay, a critical value, x equals a, is a critical number of f of x if a belongs to the domain of f of x, and the slope, or the derivative at x equals a, is 0, or f prime of a is undefined. You might have an example, like your homework, to find the critical values of f of x, and the first thing you need to do is take the derivative. Okay, so 3 times 12, we got 36, x squared, 4 times 2 is 8x, and then set the derivative equal to 0. Alright, this has a common factor, 4x times 9x minus 2, and when you solve this for 0, for x, you're going to get x equals 0. When you solve this for x, you're going to get x equals 2/9. So x equals 0 and x equals 2/9 are critical values of f of x. You might want to pause the video here to read or write down the guidelines for finding these critical numbers. Next, we're going to do 5 examples of finding critical values of functions. Try pausing the video now to try number 1. Keep going if you want hints or to watch me do parts of it. My first hint is to take the derivative and then set that equal to 0. Now factor out the GCF and solve for x. When you solve that out, you will get that x equals 0 and x equals -2 are the critical values of f of x. Now let's try number 2. Again, pause the video to try getting the derivative and getting the solutions. Unpause when you want a hint. My first hint is the derivative. Unfortunately, this function is not factorable, which makes getting the solutions a little bit more difficult. When you have an unfactorable quadratic and you want the solutions, you should use the quadratic formula. If you've heard the song before, you can use that to help you remember it. If not, I'm going to sing you a version that goes to the tune Pop Goes the Weasel. X equals -b plus or minus square root b squared minus 4ac all over 2a. Pause here and plug in the values to make sure you have the solutions correct. Once you've plugged in the values, simplify. As you simplify the square root of 48 to 4 square root of 3, then you can divide all 3 of these coefficients by 2, and then you can split them into 2 fractions, 6 over 3 plus or minus 2 over 3 and the square root of 3 to get x plus or minus 2 square roots of 3, and these are the critical values of g of x. Alright, pause the video here to try number 3. Unpause when you need a hint or you want to check your answer. First hint is try rewriting the function so that it's in more simplified form, like this. Now try taking the derivative. Now set the derivative equal to 0 and solve for x. r equals 2 is the critical value of r of x. Now pause the video and try number 4. Unpause when you would like a hint. Use the quotient rule when taking the derivative of a function that has a fraction. Once you have the derivative, -20x over x squared plus 1 squared, set both the numerator and the denominator equal to 0. solve for x on each case. When you solve for the numerator, you're going to get x equals 0. When you solve the denominator, you're going to get x equals plus or minus the square root of negative 1, which, if you remember from Algebra 2, is plus or minus I. That's an imaginary root, so the only critical value of m of x is x equals 0. Now let's try our final example for critical values, number 5. F of x equals sine x minus cosine x. Pause here unless you need a hint. The derivative of f of x is cosine x plus sine x, and then when you set that equal to 0 and subtract sine x from both sides, you're going to get this function that you can't really do much with. So what you need to look at is the unit circle. Pretend that's a really good circle. And we're looking for the angles whose sine and cosine values are the same. Can you think of angles whose sine and cosine values are the same? Hopefully you thought of the reference angle pi over 4. All the way around the unit circle, the sine and cosine values of the reference angle pi over 4 are the square root of 2 over 2. But only two of these angles have the opposite sign, positive and negative, for cosine and sine. 3 pi over 4 and 7 pi over 4 have opposite sign values for the cosine and sine. In the fourth quadrant, the cosine is negative and the sine is positive. In the fourth quadrant, the cosine is positive and the sine is negative. So the two values where the cosine x equals negative sine x on the interval from 0 to 2 pi are 3 pi over 4 and 7 pi over 4. This concludes the first video on extrema for Mrs. Rose's AB Calculus class.